Hello, welcome back to my channel, Easy Electrical Engineering. In the previous classes, we have seen the active and passive elements, types of active and passive elements, particularly passive elements, resistor, inductor, capacitor, and the voltage and current relationship between voltage and current relationships in resistor, inductor, and capacitor. Those video lectures already we have completed in the previous classes. In this class, we will see the arrangements of these RLC parameters. There can be any kind of arrangement out of which we will discuss two different kinds of arrangements. See, the first one is series arrangement and the second one is parallel arrangement. So when a number of resistors are connected in series, then what will happen and how can we minimize that circuit? Similarly, when the number of resistors are connected in parallel, then what will happen and how can we minimize? We will see the resistors first, followed by inductors and capacitors. Okay, so the first one, series combination. Let us consider R1 and R2. Two resistors are there. If these two resistors are connected in series, how we can say these resistors are connected in series means the same amount of current should flow in these two resistors. Not only to, if you want to say n number of resistors, let us say if we have R1, R2, R3, up to so on, Rn. If all these resistors are connected in series, means all these resistors should contain same amount of current, which means same current should flow. So this is the condition. And not only that, the output of one resistor is connected to the input of another resistor. Look at here in the circuit R1. See, the current is entering here. The current is starting from the source voltage. It is coming like this and it is entering here and it is leaving here. So the output of R1 is going into R2. Actually, this connection is also called as cascaded connection. One element output is given to another element input. That means these two elements are said to be in cascade. Element in the sense resistor, inductor, and capacitor. So, for example, we are considering two resistors R1 and R2. These two resistors are connected in series. You can see here, these two are connected in series. R1 has two terminals, namely a positive terminal and a negative terminal. So let us consider, suppose it is has two hands. Let us say this is right hand, this is left hand. Similarly, R2 is also having two terminals, right hand and left hand. One terminal means one hand. You see, the left hand of R1 is connected to right hand of R, sorry, right hand of R2. So when this kind of connection, if you see, this means a cascade connection. When you see this kind of connection, then that means R1 and R2 are connected in series. Okay, so you can clearly observe R1 and R2 both are connected in series. When a number of resistors are connected in series, the equivalent resistance means we can simplify this circuit. We can eliminate these two resistors and we can simplify this circuit when we have not only two, if we have multiple also like this, then we can simplify that circuit and replace with a single resistor. How can we replace? We will see. This is the formula to replace that circuit. How can we replace those two resistors, namely R1 and R2, can be replaced by a single resistor, and this resistor RT means total resistance, and the same current is flowing here, and this is the supply voltage V, positive terminal and negative terminal. You can see RT is the total voltage. So this circuit is completely simplified or modified into this circuit. So instead of keeping two resistors, we can keep one resistor like this. And this resistance can be calculated like this. So this is the basic rule. What is this rule? When a number of resistors are connected in series, then the equivalent resistance, which means total resistance, is the sum of all individual resistances. So two resistors are connected in series. Sum of these two resistances, that means R1 plus R2 will be the total resistance. Let us say if we have n number of resistors, R1, R2, R3, R4, R5 up to Rn. For this case, what should be the total resistance? The total resistance RT will be R1 plus R2 plus R3 plus so on up to Rn. So this is how the circuit can be simplified like this. So all these n number of resistors can be replaced and simplified into a simple circuit like this. And the equivalent or the total resistance can be calculated by adding all these resistors. Okay, so for this series circuit, we have few noting points. We should note few points for this series circuit, and all these points are given here in the note. The first point is if some elements are said to be in series, then these are the must possible conditions. The first one, same current flows through each resistor. For each and every resistor, the same current has to be flow. And second point is voltage drop is also additive. Let us say for R1, the voltage drop is V1 here. So V1 is voltage drop across R1, V2 is the voltage drop across R2. So that means the voltage drops VR1 plus VR2 are additive, which will be equal to the supply voltage V. So this is the second point. Voltage drops are also additive, which means we must add voltage drops also. Similarly, the third point, resistances are also additive to get this total resistance. And power is also additive. So resistances are adding, voltages are adding. Similarly, the powers are also adding, which means suppose P suffix R1 is the power loss in resistor 1, P suffix R2 is the power loss in resistor 2. That means PR1 plus PR2 is equal to the total power loss in this circuit. So that means the powers are also additive. Voltage drops additive, resistance also additive. Similarly, the power also. And the last one, the applied voltage equals to the sum of different voltage drops. This already we have written. The supply voltage is V, which means the applied voltage across these resistors, which is nothing but the same as the voltage drops of those two resistors. So these are the few points we must note for the series circuit of the resistor. Okay, now we will see the parallel combination. See, this is the circuit of parallel combinations of resistors, and you see here also for namesake we have considered two resistors R1 and R2. So these two resistors are connected in parallel. How can we say these two are in parallel? For series, we have seen cascade connection of R1 and R2. Then we can say these two are connected in parallel. Or you can say right hand and left hand, here right hand, left hand. So the left hand, right hand is connected, paired. Okay. In the similar way, we can also express parallel connections. Let us take this is the right hand and this is the left hand of R1. This and this is the left hand of R2. Now let us assume R1 is you, R2 will be your friend. Now the right hands of both resistors must be connected. Right hands of both resistors must be connected, and the same manner the left hands of the both resistors must be connected. Then only these two are connected in parallel. Right hand should be connected, and left hand should be connected. Then only these two resistors R1 and R2 both are connected in parallel. That means these two are in parallel. When this condition is accepted, then only we can say those are parallel. Okay, so when these two resistors are connected in parallel, then how can we minimize this circuit? See, here are the statement. So when a number of resistors, here we have considered two, resistors are connected in parallel, then the reciprocal of the total resistance, reciprocal means 1 by RT, total resistance means, is equal to the sum of the reciprocals of the individual resistances. That means the total resistance reciprocal, which means 1 by RT, the reciprocal of the total resistance, is equal to the sum of the reciprocals of the individual resistances. You see, we have considered two resistors, so 1 by R1 plus 1 by R2. Sir, what if we have R1, R2, R3 and more up to Rn? Then what we will do? Same principle will be applicable. So 1 by RT, which means the reciprocal of total resistance is nothing but 1 by R1 plus 1 by R2 plus 1 by R3 plus so on 1 by Rn. So this is how we can add all the resistors when these two are connected in parallel. And we also see few points for the parallel connection. The first one is same voltage should appear across all the resistors. When R1 and R2 are connected in parallel connection, the voltage must be same. That means VR1 must be equal to VR2 must be equal to the supply voltage, because these two resistors are connected in parallel to the supply. So voltages must be same in parallel. But whereas in series we have seen current must be same. There current must be in series, current must be same. In voltage, sorry, in parallel, voltage must be same. Right. The second point, branch currents are additive. Here, branch currents means you can see I1 and I2 are there here. I1, I2 are said to be branch currents. So these branch currents should be additive. That means I1 plus I2 will give you the total current I. So I is dividing here into two parts, I1 and I2. So the branch current should be additive. And the third point, the power is also additive. Previously, we have seen for the series, the same way here also the total power loss will be power loss in R1 resistor plus power loss in R2 resistor. So these are the points we should remember for the series and parallel circuits of RLC elements. However, we have seen only resistor now. In the next video, we will see for inductors and capacitors. Thank you.